Hi guys, welcome to my YouTube channel. In this video, I will cover Pandas library of Python. So in this video, I'll just cover the series in Pandas, and I'll create a next video for data frame and pivot tables because I don't want to keep videos too long. So let's start without any further delay. So Pandas library is generally used in machine learning to handle the data sets and to process the data sets. For example, most of the data that is present to us is in CSV file, right? Most of the data is in CSV files. To handle those files and to filter the unknown and null values or clean up the data, we use Pandas library in Python. So initially in Pandas you can create a series as well. So series you can create using multiple data structures. So for example, this is a simple array in Python or list in Python, and you can just call the Pandas series function to create a series out of it. So series is nothing, it just arrays the data in tabular form along with the indexes. So as you can see, as I have created a series using a list, it just gives me in a tabular form along with the indexes. So 0 to 1, 1, 2, 3, 4, these are indexes, and the rest are the values, and it also shows you the data type of the values. And irrespective of that, you can also choose your own index values as well. So if you don't want to go with the default values, the integer values, then you can just provide the indexes in a separate parameter, and it will just allocate them as indexes. As you can see in the output here, the indexes are ABC instead of 0, 1, 2, 3, 4. Similarly, you can create series using a dictionary or a scalar value as well. So you can provide a dictionary, and you can just call the series method here, and it will just take the key value pair as a data and index. So key will become index, and the data, the values will become the values of the series. And in case of a scalar value, it will just take all the index value that you have provided, and it will just it will just assign the same value to all of them. So this is how a scalar series is created. Now there are multiple operations that can be done on a series. So these operations are like similar to a NumPy. Like NumPy as well, you can just add, multiply, or do some binary operations on the whole series at a single time. So you don't have to use a for loop or something like that. You can just do the operation on the whole series like this. So as you can see, I'm adding a 5 in this first statement, and in the next statement I'm just multiplying it by 2, and in the result you can see initially series was 10, 20, 30 and 40, right? So as you can see, the result is applied to the whole series instead of on a single value or something like that. So there are some predefined functions as well provided by the Pandas on series, like mean, max, aggregate and all those things, aggregate functions. We'll look into more about this in the later part of the video. Next, here I have created a series. Now you can access the series like you have done it in NumPy and other things, like using indexes or using the custom indexes you have created. So here I have created using custom indexes, right? So I can just use those indexes to access a particular element in the series. So as you can see, I'm just trying to access the value that is present at index A, which is 10, and then I'm trying to access the values at multiple indexes in a single go. So you can just provide the list of indexes for which you want to access the values of, and it will just give you the result accordingly. Also, if you don't want to go with the indexes, you can just go with the integer index that by default is created by the Pandas, right? So instead of doing it like this, you can just use the similar annotations of NumPy or list in Python, and you can just access the elements using the integer indexes. Like I'm trying to access the first element of series using the 0th index, and I'm trying to access multiple elements using this colon notation, where it says that access all the elements from index 1 to index 3. So you can do the same. Plus this type of annotation works with this custom index as well. So as you can see here, these are integer index, right? But this type of annotation also works with the custom indexes, the ones you have provided in order. So here you can see as you have provided these indexes in the order, right? And here you are saying include all the elements from B to D. There is one observation though. When you are trying to access the multiple elements using this integer indexes, as you can see, only B, C, D are there, right? So initially B, C, D belongs to the index of 1, 2 and 3, right? So the fourth one, that is E, it's not included here. It's only giving you B, C, and D elements. But in case of this type of annotation where you are using custom indexes, you can see both of them are included. B and D, both of them are included, and they are coming in the output. So this is just the difference here in the default behavior with integer indexes as well as the custom indexes. Now there are other methods as well to access the elements in a series, which is ilock and lock. So you can use ilock as well as lock to access the elements in series. So in ilock you can just provide the positions, the integer indexes, like in the same way that we have done here. So instead of directly accessing like that, you can also use these methods here, 0 and 1 to 4. It will give you the same result as we have seen above. Same if you want to go with the custom indexes like labels, we call them labels in the series. So you can do the same thing here as well, like we have done it here. It will give you the exact same result. So here I'm trying to access the value present at label B, which is 20, and then I'm trying to access the labels from B to D, and the same, both B and D are inclusive here. And the behavior is still same here. So here, as you can see in the integer values, the fourth index is not included, which is E, right? But in case of the labels, both the labels are inclusive. So B and D, we are both the labels are coming in the result. Also, you can also use some conditions to render the series based on some conditions. So here you can do something like this as well, like provide all the values whose value is greater than 25, or you can provide any custom condition that you want, and it will just filter the series according to the result. It's basically filtering the series based on a condition. So as you can see on this condition, if you go to the original series, values greater than 25 are the last three, right? 30, 48, 50, and hence you are getting the same in the result as well. Now if you want to access all the values of a series, like there are various other parameter arguments that are provided by the pandas. Here you can access all the values of the series as a numpy array. So you want to convert your series back into the numpy array using all the values, then you can do it something like this, as dot values. So it will just provide you all the values of the series as a numpy array. Similarly, if you want to get all the indexes present in the series, it will just provide you the indexes as well, and it will also provide you the type of that index object. So for checking the data type of a value in a series, you can just use this parameter data type, which is by default integer 64, and shape, size, all those methods are same as numpy. So shape will provide you the shape will provide you the shape of the series. So in series there is no multi-dimensional shape, right? The series is a linear data structure. So here you will mostly see one single value, and it generally is same as size, because series is a linear data structure, right? So it has only one dimension. So here the shape and size will be same, but in case of data frames that we will see in the later video, this could be different, as you have seen in the numpy arrays as well, right? When you create multi-dimensional arrays, the matrix when you create, the shape is shape tells you in what dimensions how many rows or columns are, but size give you the exact size of element. I mean, how many total elements are present in the matrix, right? In numpy same is here, but in series, as that it is always single dimensional, right? It is linear data structure, so shape and size values are generally same. Now this is unique function. It tells you if the series has unique values or not. So by default it is true, because in my series there is no duplicated value, right? 10, 20, 30, 40, 50. So let me change it to 20 again, and let me run this method again, and as you can see, is unique is now false, because my series also has a duplicated value now, right? So you can see that it's returning a false output. Similarly, there are other functions to find out if a series has null values, empty, or dimensions of the series as well. So if there are any nan present in series, or series is empty, then these will return you the values accordingly. They just return the boolean values, boolean output, and tells you if the series has any nan or is the series empty. Then there is another parameter provided by the Python, which is the dimension, to check the dimension of the series. So series is a single dimension, right? So it will it's always one. For series it's always one, because it's a linear data structure, right? It cannot have multiple dimensions, so this value will be always one for series. Now there are some statistical and summary methods as well for quick calculations, like sum, mean, medium, standard deviation, min, max, like we have seen in NumPy arrays, right? So the same is present here. Sum will give you the sum of all the values present in the series. So if you will sum the values of this series 10, 30, 40, 50, let me change it back to 30 and execute it again. And let's execute this cell again. So as you can see, the sum is 150, right, for all the 5 values. So here it will provide you the sum, mean, medium, standard deviation, and minimum and maximum element present in the series as well. So maximum is 15, minimum is 10. And if you want to see all the summary statistics in a single go, you can use this describe method. So it basically provides you the count, mean, standard deviation, minimum, 25%, 55%, and all those things as a nice summary of the whole statistics thing in the series. You can just use this function to calculate all of them in a single go. Now you can just perform other operations and normal operations as well in the series, like counting and sorting and all those things. So like as we like DataFrames also, if you work with DataFrames, here is also the head and tail function provided by the Python. So it will just give you the partial view of the series from the top or from the bottom. So head gives you the partial view of series from the top and tail from the bottom. By default the value is 5. So if I, let's say, remove this 3 here and execute the cell, so as you can see all 5 of them are coming. Let me go up. Yeah, as you can see all 5 of them are coming, right? So by default the value is 5 for both of them, but you can provide your own integer as well. So how much view you want in your output, how many rows actually you want in the output. So tail gives you the bottom part of the series. As you can see, the last 2 indexes are coming in the tail, and in the head the top 3 indexes are coming. And same way it will just there is the unique method which gives you the unique values that are present in the series. So my whole series is unique, right? Let's change that again. So let me again make it 20 and execute it. Then let's execute this as well, and then this as well. So as you can see the unique values. Now if you will see, 20 is coming only a single time, right? So we have 22 times in our series, right? Now in the output 20 is coming only once. So it will just give you the all values that are unique in your series. Now if you want the count of your unique values, then you can also use this function like and unique. It will just give you the count of unique values in your series. So 20 is present 2 times and all the other 3 values are present only once. Then the value count is there. Sorry, I made a mistake. So number of unique values, it will just provide you the number of unique values present in the series. So we have only 4 unique values, right? It will just give you the count of the unique values, and value count will give you the count of each unique value. So like 20 is coming twice, and 10, all the other values are coming once in the series, right? So this is how it goes. Then you can sort your series as well. What's an ascending or descending order? You can just provide if you want ascending or descending order, and it will just sort your series accordingly based on the values. If you want to sort your series based on the indexes, not on the values, you can also do that using this sort index function provided by the library. And let me just open it. So here, as you can see, in descending order by values, the series is sorted by this sort value function, and by sort index function, it just gives you the series in the ascending order. So our indexes were already sorted, right? So it's the result is same as the original series, but you can try it on your own. It will just sort your series in the based on the indexes. Now data manipulation is like NumPy array only. You don't have to go into the for loops and something like that. You can just provide your operation on the whole series. So multiply by 2, it will just multiply all the values of the series by 2. Similarly, you can just provide your lambda function as well. Like instead of using these primitive operations, you can just create your own function, and you can just use that here as a lambda function, and it will just perform that operation in the series. So here I am just finding out the power of whole value. So I'm just getting the square of the values, but you can perform complex condition logic as well here. So you can just write a big function with all the complex logic, and you can just pass it here, and it will be applied to the each element of your series. Now there is also a replace function which replaces the particular value. So here I'm just trying to replace the 20 by 25. let me execute this cell again. So as you can see, I have 20 in two places now, right, in my series. So both the values are replaced by the 25. So here you can just tell what value you want to replace, and it will just replace the value in the whole series for you. Then you can just provide a custom name to your series as well. So if you do that, it will just give the series a custom name. Just you can just define the behavior here, like what do you what does this series represent. So you can just provide a name to your series as well. Now handling the missing values is also very similar to NumPy arrays and in Python. So there are very similar functionality available here as well, like is null, not null, fill na, drop na. So all these methods you might have seen before. So is null, it will just tell you so I've just created a series, right, with two values as none. So is null, it will just give you whether series has null values or not. So if you see the output of the null values in series, so you can see wherever the value is null, which is represented by this none keyword in Python. So you can see the value is coming true, right? So all these places the value is null. So is null just tells you at what place the value is null. Then similar function is not null, which is the reverse of this function. So it will just tell you where the value is not null. Then fill na 0, it will let me scroll it. Fill na with 0, it will just replace the null values with whatever value you have provided here. So if I just provide here at 5, and let's make it scrollable again. Yeah, here. So I have provided 5 here, and then you can see all the null values are replaced by 5 in my series. Now if you want to drop your null values, that you also can do. So as you have seen, the result of the drop na is only 3 rows, right, because two rows have their null values, right? So the changes that we are making in these functions, they are not in place. It will just give you a new series with the output, with the result, with the desired output. The original series will always remain same. For that you have to change the reference. You have to assign this the output to your original series if you want to modify the original series as well. Now you can filter values as well. So as I've shown you before, you can pass complex functions while sorting your values, or you can apply your conditional logic while custom functions, right? So here I'm doing the same. Here I want to filter the values greater than the mean. So I'm just saying in my series, just give me all the values where the value is greater than the mean of the series. Then after filtering it, I'm just sorting the values in descending order. So as you see in my result, if you will calculate the mean of this particular series, right, so we have seen it will be 50, 30, 80, 90. It will be somewhat around 20 to 30, right? So all the values that are greater than that, they are coming first. So we have 30, 50 and 40 here. We have 50 and 40 here, and I have sorted them in descending order, right? So that's why 50 is coming on the top. So you can you can perform functions like that as well in the series, basically chaining the method together, because here the output will be a series, right? So you can use another function of the series as well. So here as well, I can just chain another method of the series because the output is still a series, right? So this is how chaining and conditional filtering and everything works in the series. Now this is all about series. In the next video I'll cover data frames and pivot tables, because I don't want to extend this video to very long time. And see you in the another video, and please like, share and subscribe my channel.